Greetings, folks. Are you familiar with specifications grading? It's a term coined by Linda Nilsson in her book by the same name. As the subtitle suggests, the idea is to restore rigor, motivate students, and save faculty time through this unique alternative grading scheme. I won't go into too much of the theory behind it, but long story short, under specifications grading, assignments are graded on a pass-fail basis, satisfactory, unsatisfactory basis. And as you can see here, I've set up a spreadsheet that manages the specifications grading calculations for you. Of course, there are many different variations on this and many different ways to implement the ideas that Nilsson describes, but I would posit that most electronic management learning platforms that we have as college professors are not capable of handling this system. And so what I want to do today is show you some of the features of the software called Grist, that's Grist, which I think provides a great platform for setting up your own specification grading system. As you see here, I've created a spreadsheet and the grading outcomes and calculations are entirely automated. So as I change these outcomes, the grades will change in the corresponding manner. The cool thing about Grist is that it allows you to write Python code as formulas. So you can just use standard Python syntax to tell the software exactly how you want it to process all the information and all the data that you have put in. So in this video, I'll walk you through how I've set this up, talk about some of the cool features of Grist, and just give you some tips on how you might use this software to set up your own specifications grading system according to your personal preferences and pedagogical approaches. So first things first, let's talk about how to get Grist installed and set up and running. This is open source software, so you can host it and run it yourself. As you'll see in their GitHub repo here, they offer a standalone desktop version, which is available for both Linux, Mac OS, and Windows. And there's also Grist Core, which is the version of the software that runs on a server and can be accessed through a web browser. As you can see, Grist Core can be run from Docker, which is excellent. However, it is lacking a few features that you would get in the enterprise version. Most notably, it has no built-in authentication as far as I could tell when I installed it and ran it. So you would need to bring your own authentication solution. This does add an extra layer of complexity for most self-hosters. Fortunately, Grist also provides hosted online cloud versions, and for individuals and small projects, small teams, there is a free version. If you don't already have an authentication solution set up and you're working with other people, like a TA, for example, I would recommend that you use the version of Grist hosted on their servers for free. However, if you're just an individual instructor and you don't need to collaborate with anybody, I would recommend using the desktop version of Grist, which is fully local and just runs on your device only. So if you open up Grist and create a new document, you would see a page like this, minus the fact that it would be completely empty. But go ahead and set up your columns for your intakes, your quizzes, if you're doing those, any other things you might want to keep track of, like extensions used or resubmissions used or whatever else it may be. But once you have your column set up, you can start leveraging some of Grist's really cool features to really elevate and automate this grading system. So the first thing is assigning a unique ID to each student. This can be helpful for some of the features I'll show you later, where you can actually allow students limited access to this sheet to be able to see their grades, but without seeing the names of any of the students. They only see their unique hash, which you can provide to them at the start of the semester. So I've gone ahead and filled in the name and the email of this example student. And here is the power of Grist, is that you can write actual Python code by going in, creating a new column that is a formula column. And you'll have the option to write your Python code here. As you can see here in the cell that I've already filled out, I'm just using standard Python syntax to create a hash of the student's name, last name, email, and a unique salt that I've added just for a little bit more security to prevent rainbow table attacks. If you're not familiar with Python, AI language models are fantastic at writing short and simple code like this. But simply what a hash does is take a given input and produce a unique output with very little chance of overlapping between similar inputs. So whereas the previous cell was the hash calculation, here I'm just returning the hash. In Grist, you use this $ and then the name of the column syntax to reference a particular column. So I want to hide how the hash is being calculated. And so I'm just saying return the value that is in this cell here. And so these will always be the same. If you're wondering what the ID of a column is for the purposes of the code here, you can always go and click on the column and find the column ID written there. So let's move to the next column. If you go to any column and you hit column options, you will see everything you can change about the column, including limiting the type of data that is in the column. So in this case, I want it to be a choice column. There's a finite number of options that can be selected. I've named each of my assignment categories after these gemstones, and that's why you see these names here. But you'll note you can color code them the way I've done by clicking on the name, or if we just create an entirely new one, I'll show you the process from scratch, hit enter, and you can select the fill to be whatever color you want. So now if we double click this cell, we have the option to put test in there, and it has this color. So moving along down the sheet, the outcome column has these satisfactory, unsatisfactory choices. The way I've set up the logic here, you do need to have a satisfactory or unsatisfactory option selected. And later on, the code will look at the assignment, look at the number of points that's worth, and then assign those points if the outcome is satisfactory. If we scroll over to the quizzes column here, as you'll see, I want these to be an integer, so a whole number. You could have it set up as a text box where you can just free enter the number, or you can have it as a spinner where you can just click these buttons up and down. Once again, this is just a matter of personal preference and how you want to enter things in. And to that point of personal preference, my TA prefers to enter in my quiz grades based on the number of questions correct rather than calculate the percentage average. So using the power of Python in Grist, I've written code that simply takes all of the quiz values from the quiz columns listed here. I can write out the total number of points available in the corresponding quiz. And then all this logic here is simply to calculate the percent average of all the quiz scores combined. And so you can see as I increase these scores here, the quiz average goes up. I also drop a certain number of quizzes every semester, and so I've built that right into the logic. Once again, you could have an LLM output all of this if you're just very clear and specific about how you want the code to function. An LLM will tend to spit out a function if you're writing in Python, but you can simply tell it, I don't want a function, just give me direct code, and it should perform just fine. Scrolling over, we see participation. I use participation as a plus-minus modifier on the final grade, and so you'll see in the logic I write for the specification grade, it accounts for this. Moving over one, you'll see we have a type error in this cell. That's because back here I added in this new type, or I've entered in this new type that was not accounted for in the code. So if I change this and then scroll back over, you'll see now there's no more type errors. However, the student still has an F because of the logic that I've implemented. But first, the points earned column, once again, this is more Python. Try to minimize the number of columns where you're doing calculations. So the total number of grade points they've earned based on the assignments they've done is stored in this bit of code here. And I've just written a dictionary that corresponds the name of the assignment with the number of points they'll earn there. And once again, it just calculates the total number of grade points earned based on if the assignments were satisfactory or not. And then over here in the specifications column, same thing, just some basic Python logic to check if they've met the conditions I've set to earn each grade category, and to then go ahead and add the plus or the minus modifier according to what's in the participation category. Then lastly, we have a cell that just checks if there's a duplicate in the hash. That's very unlikely, but just in case, this should turn yellow if ever there was a duplicate hash in the spreadsheet here. You don't want students having the same ID on accident. Another cool thing about Grist is the widgets, which are these little add-ons that can make data entry and data visualization a lot easier. So if you recall, the example I showed in the beginning had a little card section where you could just quickly enter in the outcomes and grades and quizzes for each student as you scroll through the spreadsheet. So the way you can do that is by going to Add New, Add a Widget to Page. What I had was the card type widget. It's going to be based on this grades data. And then you simply hit Add to Page. And so this card type widget now pops up with all of the data that is available in each row of the spreadsheet. But what we want is to have a simplified view with only the information that's actually relevant to us. So we can go here, Widget Options, and Edit Card Layout. Or first things first, we actually want to just decide what fields are visible. So maybe we only want their name. We don't care about their hash. We don't care about that. All we care about is the intakes and the quizzes. And so now, as you can see, it's looking like a much more streamlined card. But as I mentioned, you can edit the layout. And so if you want to have all the quizzes just stacked in the bottom row here, you can just move this there. It's a little bit fiddly, but now this column is rearranged. And similarly, you could drag something over here if you wanted to do that, or however else you prefer. I quite like this, where the outcome is here, and well, actually, I would probably swap it. I'd probably do something like this, where the intake is on the left side and the outcome is on the right side. And then once you have that done, you can just hit save. And so as you're browsing through the sheet, you can just be using the arrow keys to scroll down, and you can very quickly just enter in this information for each student. So returning to our example sheet, you can see how you might do this if you're actually grading is sort this last name column alphabetically, if that's how you prefer to organize things. And for any given intake, you can simply use your arrow keys to scroll down to each student, entering the outcomes, leave it blank if they didn't submit anything, and then inputting the correct assignments and outcomes as you go down the sheet. Just double clicking and entering in the information as so. The last thing I'll share here is the access permissions. So as I mentioned, you might want students to be able to view this sheet and see all the hashes so they can see their grades, but obviously not see the names or other information that they don't need to see. The way we can control what the public users see is by going to Share, Manage Users. Here, you could add another editor like a TA or something like that. But to configure what the public users can see, you go to Open Access Rules. And as you can see by default, the viewer, that's the lowest level of access, that's the public link, can see all the columns. We want to override this by creating a table rule for this particular table, the grades table. Then we want to go here, add column rule, and then we want to list out all the columns that we don't want them to see. So we don't want them to see the last name. We don't want them to see the first name. We don't want them to see the email, and we don't want them to see the hash calculation. And then we can just copy this syntax here for the public link. So user.access in viewer. And then we say they don't even have read permissions. And of course, they don't have update permissions to these columns. So then we hit save. And if we return to the share screen, we can turn public access on. Do hit confirm to save all of this. Then if we open a new incognito tab where we're not logged in and we put in the public link as we would, we can see the hash and the intake outcomes, but not any of the names or anything like that. And we don't have permission to change any of these columns. They're locked. So using this method, you can make your grading sheet publicly available to students so they can see their grades and where they stand in the class at any time. I hope that's been helpful and given you some ideas. Please let me know if you have any questions or if there's anything else you'd like me to cover about this piece of software. Take care, folks.